Chances are you've talked to a chatbot sometime this week. Maybe you were even blown away by its answers. But did you ever stop and think, what is actually going on inside that thing? How does it know what to say? Well, today, we're going to pull back the curtain and demystify the AI mind.
It really all comes down to this one single question. When you type something in, how on earth does an AI come up with a response that's coherent, that's relevant, and sometimes, honestly, surprisingly creative? And the answer? Well, it's kind of both incredibly simple and mind-blowingly complex at the same time.
You see, at its absolute, most fundamental level, a large language model is just playing a very, very sophisticated game of what comes next. It's a prediction engine, but on a scale that is, well, it's almost impossible to even wrap your head around.
Okay, let's try an analogy to make this super clear. Imagine you find a little piece of a movie script, but the AI's next line has been ripped off. Your only job is to guess the very first word of that missing line. That's it. Once you've got it, you guess the next word, and then the next. And that, right there, is the basic idea behind what a large language model is doing, over and over again.
So, okay, that leads us right to a nice, clean definition. A large language model, or LLM, is basically just a powerful, sophisticated mathematical function, and it's designed to do one thing and do it exceptionally well: predict the next word in any sequence of text. It's not thinking, it's not feeling, it's calculating.
This whole process works in what you can call an auto-complete loop. So the model grabs your prompt, it predicts just one word, and then, here's the clever part, it sticks that new word onto the end of the text. It then looks at this new, slightly longer piece of text to predict the next word, repeating this loop again and again until the response feels complete.
But here's a really crucial detail. The model doesn't just pick one single correct word. No, instead, it generates a whole list of probabilities for every single word it knows that could possibly come next. So for the phrase, the cat sat on the word mat might have the highest probability for sure, but rug could be a close second and floor a little behind that. This is why you can ask the same question twice and get different answers. The model mixes in a little bit of randomness so it doesn't sound like a robot.
So the big question is, how does it get so incredibly good at this guessing game? Well, the answer is practice, an astronomical amount of practice. And folks, the scale of that practice, this is where things just get absolutely wild. Seriously? Just try to get your head around this number for a second. To read all the text that an early model like GPT-3 was trained on, you would have to sit down and read nonstop 24/7 for over 2,500 years. And the newer models, they're trained on way, way more data than that. The model learns the patterns, the context, the grammar, and the facts of our world by basically digesting a huge chunk of the internet.
So how does it store all that learning? Well, you can think of the model like a gigantic, ridiculously complex machine with hundreds of billions of tiny little dials. These dials are called its parameters. And the whole training process is really just about tuning these dials over and over and over until the machine gets really, really good at that next word prediction game.
All right, let's put that tuning process into perspective. I want you to imagine, let's say you were a human supercomputer, and you could perform 1 billion calculations every single second. How long do you think it would take you to do all the math required to train one of these major LLMs? Go on, take a guess.
Yeah, not even close. It would take you over 100 million years. This is just a staggering amount of computation, and it's exactly why training these models requires these massive, sprawling data centers filled with thousands of specialized computer chips.
Okay, so it's a super-powered autocomplete, but that's not the whole story, not by a long shot. Because a model that's only trained on random text from the internet, well, it might not be very helpful or safe. There's another absolutely crucial step. You see, training really happens in 2 big stages. First up, you've got pre-training. This is where the model just swallows the internet, basically, learning to predict the next word from trillions of examples. But that raw model isn't very useful. The real magic, the thing that makes it useful to us, happens in the fine-tuning stage. This is where humans get involved, giving the model feedback, rating its answers, and correcting its mistakes to teach it how to be helpful, how to follow instructions, and how to be safe. This second step is what turns a simple text predictor into a genuinely useful assistant.
So what was the big breakthrough that made all of this possible? What unlocked this massive scale? Well, the secret sauce is an incredible architecture that was invented back in 2017 called the transformer. It changed everything. Before the transformer came along, AI models had to read text pretty much like you and I do. One word at a time, in order. And as you can imagine, that was incredibly slow, and it made it really hard to understand the context of a long sentence. Transformers completely flip the script. They're designed to soak it all in at once, processing every single word in parallel. This is what allows them to be trained on those massive, massive data sets.
And the key trick inside a transformer, the thing that makes it all work, is a mechanism called attention. Here's the deal. After it turns words into long lists of numbers, this attention mechanism allows all those numbers to interact. I mean, it literally lets them talk to one another. This lets the model figure out how important every other word in the sentence is when it's trying to understand one specific word.
This is exactly how the model figures out the difference between, say, a river bank and an investment bank. How does it know which one you mean? It pays attention. The mechanism looks at all the surrounding words, river or investment, to figure out the precise meaning from the context. It's brilliant.
And that brings us to our final, and honestly, maybe the most fascinating point about these models. Their incredible abilities. They're not programmed in the way you traditionally think.
See, nobody sits down and writes a line of code that says, here's how you write a poem, or here is the step-by-step guide to explaining quantum physics. No way. Instead, all of these amazing complex skills simply emerge. They bubble up from that one single, simple goal: predict the next word. Just repeat it across trillions of examples by tuning those billions of parameter dials.
And this is where it gets really interesting. It's a paradox, right? The researchers, they know how the model learns. They built the whole system. But because all that behavior just emerges from the insanely complex interactions of billions of parameters, trying to look inside and understand why it chose one specific word over another is, well, it's incredibly difficult. It's a bit of a black box.
So that leaves us with a really deep question to think about. We've just seen that all these complex abilities, reasoning, creativity, language, can literally emerge from one simple goal: predict the next word. So, if that kind of intelligence can just arise from learning statistical patterns and data, what does that say about our own minds? It's a huge question, and one that will keep researchers and all of us thinking for a very long time. Thanks for joining me for this deep dive.